Hi everyone, I am Dr. PSV Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain the single slit diffraction. Actually, in the earlier article, the single slit diffraction intensity equation or the formula was derived. Now we are going to analyze that part. Actually, since this is the huge one, that's why we are dividing this one into two parts and coming to the intensity distribution analysis. Actually, at the end of this lecture, the student will able to learn the concept of single slit diffraction, moreover Fraunhofer diffraction due to single slit, and the student can understand the distribution of intensity of light at various points on the screen. So now coming to the single slit diffraction, the Fraunhofer diffraction at the single slit. Say we are just considering this is the single slit, a rectangular slit whose length is perpendicular to the plane of the board or the paper, and the width of this one is given by small a is the width of the slit. Actually, from the sideway the light rays are passing through the slit. Because of diffraction, the light rays are bending and the angle of deviation is given by theta. Again, a rectangular slit is considered whose length is perpendicular to the plane of the board, and the width of this one is given by small a, and from the sideway the light rays are passing and they are focusing at the point P1 rather than at the point P. Why? Because of bending we get the intensity or we get the image at the point P. What kind of intensity we get? On the screen, actually we get the central maximum, first order, second order like this, first order, second order like this we get. So this is the central maximum, first order maximum given by I1, second order maximum given by I2, a symmetric pattern we get. So mathematically we will analyze the same. For that, actually the intensity formula already we derived earlier, that is given by I is equal to I naught sin square beta by beta square. The intensity, the resultant intensity on the screen at any point is given by I is equal to I naught sin square beta by beta square. So in this one, what is beta? Beta is pi a sin theta by lambda. Pi a sin theta by lambda. Now where do we find the maxima? Where do we find the minima? What are the conditions for maxima? What are the conditions for minima? For that, suppose if I take beta is equal to 0, I take beta is equal to 0, say, actually what we get here, sin beta, sin 0 by 0, 0 by 0 is actually undefined. That's why what we take in this one, limit beta tends to 0, sin beta by beta is equal to 1. That's why if you take beta is equal to 0, what do you get here? I is equal to I naught means maximum, it is representing the central maximum, as beta values are taken on the x-axis or theta values are taken at beta is equal to 0, we get the maximum intensity, central maximum position is clear. Coming to the positions of maxima, other maxima, or okay, positions of minima, let us take first. Coming to minima positions, what is meant by minimum intensity? I minimum, it is equal to 0. I minimum 0 means this sin square beta by beta square must be equal to 0, or sin beta by beta must be 0, or sin beta the numerator should be equal to 0, sin beta should be equal to 0. If sin beta is equal to 0, what is beta? Beta is equal to 0. Not only for 0, beta is equal to pi, 2 pi, 3 pi, or minus pi, minus 2 pi, minus 3 pi. For all these things, we get beta is equal to 0. Means what is beta in this one? Beta is equal to plus or minus m pi. When beta is equal to plus or minus m pi, we get the I is equal to 0 minimum intensity. What is actually beta? So beta is equal to pi a sin theta by lambda. Therefore, it is equal to plus or minus m pi, or a sin theta. This pi and pi cancelled. A sin theta is equal to plus or minus m lambda. This is the condition to observe the minimum intensity, or else theta is equal to, you will get sin inverse of plus or minus m lambda by a. At these theta values we get the minima positions. This is the first minimum, second order minimum, third order minimum. Left side also first order minimum, second order minimum, third order minimum. At different positions we get minima. What are the positions of beta values? At the values of beta is equal to plus or minus m pi, we get the minima values. Okay, central maximum is clear. Minima positions are also understood. If the maximum positions are understood, we can derive, means we can plot the graph. That graph represents the intensity distribution like this. That what we are going to discuss mathematically. Coming to the positions of secondary maxima. Actually, at the maximum intensity, I is equal to maximum means I is constant. If I is maximum, di by d beta must be equal to 0. I is maximum or whatever it may be, minimum, that is constant, then di by d beta should be 0. dy by d beta, what is di by d beta? Already we know I is this one, I naught sin beta by beta whole square, or I naught sin square beta by beta square. Just to differentiate this one using the formula u by v type, automatically you should get di by d beta must be 0. Differentiating this one, you will get finally, so beta sin beta, actually keeping beta square denominator constant, you differentiate the numerator, so 2 sin beta cos beta by beta square minus sin square beta by 2 sin square beta by beta cube, like that we get. On simplification, you will get beta cos beta minus sin beta is equal to 0, or else on simplification you will get beta is equal to tan beta. Beta minus tan beta is equal to 0, or beta is equal to tan beta. Now we have to solve this equation, but actually it is not possible to solve an equation, only one equation is there. Why? Because you give any value for beta, tan beta is also the same, means you will get infinite number of solutions for that. That's why we will solve this one by using the graphical method. So what is that graphical method? I just introduce one more new parameter as y is equal to beta and y is equal to tan beta. I am introducing another parameter y. So y is equal to beta and y is equal to tan beta. You plot a graph for y is equal to beta. It is of the form y is equal to x, means y is equal to mx plus c. C is equal to 0, m is equal to 1, slope is equal to 1. You will get a straight line. And y is equal to tan beta, you plot a graph, you will get different curves, means two graphs we get, one is straight line, another one is curves type. So the two graphs will intersect at various points. Those intersecting points will give the solutions for beta. At those beta values we will get the maxima positions. That is our method to solve this equation graphically. Observe this one, the graph. Here I plot a graph for y is equal to beta, we get a straight line, and y is equal to tan beta. These are the curves representing y is equal to tan beta, different curves. Actually tan beta is in, or tan theta is infinity, tan 90 infinity, tan 2 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, etc. we get infinite values. Tan 180, tan 2 pi, etc. we get zeros, like that. So like that we get this kind of infinity, means this kind of curves we get. These two graphs will intersect at various points. What are those points? Already at beta 0 and at 3 pi by 2, 5 pi by 2, 7 pi by 2. Actually practically beta values are, beta is equal to 0 and 3 pi by 2, 5 pi by 2, etc. 3 pi by 2 means 1.5 pi we should get. Already beta is equal to 0 we have discussed, that is the central maximum, principal maximum or central maximum already over. Now coming to other values, 3 pi by 2 means it is 1.5 pi. But actually practically instead of at 1.5 we get the value at 1.43 pi, at 2.46 pi, 3.46 pi. At these values we get the max, they are the intersecting point, that's why we get the maxima positions. Now you just say, already minima positions were cleared, minima positions we have discussed. What are the minimum positions? At the values of beta is equal plus or minus pi, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, and so on. And central maximum is clear at the value of beta is equal to 0. Now the positions of maximum at the values of beta is equal to 1.43 pi, 2.46 pi, 3.46 pi, etc. So all the points are clear. Now we can plot a graph. Means on the y-axis you take the intensity, on the x-axis you take the beta values, you just put some points, automatically join them, you will get the graph like this: central maximum, first order, second order, etc. This is the intensity distribution of the light on the screen. What is our initial motto? When the light is passing through a slit whose width d is comparable to the wavelength of light, automatically after passing through this one there exists a diffraction, means bending of light. So on the screen we find alternate maxima and minima. So this is the intensity distribution graph, that what we have seen mathematically. So in this article what we have discussed is what is the single slit diffraction, Fraunhofer diffraction due to the single slit, and also we have discussed the intensity distribution, intensity of light distribution on the screen at various points. Okay, thank you very much.